Lesson 7-4, Probability Models. A probability model is just a list of all possible outcomes in a sample space and their probabilities. Now, our focus is really not going to be on the probability models themselves, but on finding all the possible outcomes and looking at a sample space. A sample space is just the set of all possible outcomes. You can create a sample space using a tree diagram. Example 1, Lena packs 3 shirts, red, blue, and yellow, and 2 pairs of pants, denim and black, for an overnight trip. How many combinations are possible? Well, this is a problem where we could use a tree diagram to see what our sample space is. That would be all the possible combinations, and then just count how many there are. So we can start by looking at this like tree branches. Our first choice would be what shirt to wear, red, blue, or yellow. And then we're going to decide between what pair of pants. So with the red shirt, she could have two choices. She could choose denim or black pants. And then if she chose the blue shirt, she'd have 2 choices, either denim or black pants. And if she chose the yellow shirt, she'd then have 2 choices, denim or black pants. So this tree diagram shows us our sample space. She could choose a red shirt and denim pants, a red shirt and black pants, a blue shirt and denim pants, a blue shirt and black pants, a yellow shirt and denim pants, or a yellow shirt and black pants. So we can just count how many combinations there are. The end of our tree diagram, where it's branched out as far as it'll go, have 6 words at the end. Although they repeat, they go with each different color shirt. And so we can count a total of 6 combinations. The fundamental counting principle is used to find out the possible number of combinations or outcomes without having to draw a giant tree diagram. So it's going to allow us to find the total number of outcomes by multiplying the number of outcomes for each experiment. This is useful when you get into larger numbers, and also when you don't have to know what every possible combination is. Example 2, Lena packs 10 shirts, 6 pairs of pants, and 3 pairs of shoes for a vacation. How many possible combinations are there? Now, we could use a tree diagram here, but you could tell it would quickly start getting to be a lot of branches because there's 10 shirts to start with, so 10 choices. And with each of those 10 shirts, you have 6 choices on pants. And then with each of those, there's another 3 choices for shoes. So this would get to be very large very quickly. So we can simply use the fundamental counting principle. How many possible combinations are there? Well, there are 10 possible shirts. We're going to multiply that by 6 possible pairs of pants times 3 possible pairs of shoes. And so 10 times 6 times 3 is 180. And so there are 180 possible combinations. Now, had we have used a tree diagram to show that entire sample space, we would have had 180 little branches at the end of this diagram. So, fundamental counting principle, if you just need to know the number of combinations, it gets you that number very quickly.